almost everybody that I knew prior to coming to CPPCon has had nothing but good things to say about the conference and the quality of individuals that you'll see around here. Just try and take the plunge one year. You'll learn something 100% guaranteed.
Hello? No, hello? It is so great to see everybody, like to actually see an audience. So thank you guys for coming, and gals, and everything in between, and cross and all that stuff. Also, yeah, hi to YouTube audience. I'm not glad to see you because I can't see you, but I feel your ominous presence, so that's that. So my name is David Sankel, and I work at Bloomberg, and the title of this talk is Up to Code, and you might be like, David, what does up to code mean? And that is the subject of this talk, so hopefully you understand by the end of it. It's really more of an American phrase, come to find out. So let's see here. The idea for this talk, I got it like the way that I get a lot of other ideas. You ever have one of those conversations with like a mentor or someone, and you walk away from the conversation, your mind is just like blown. It's like almost every single thing that they say is like changing your worldview. Well, this happens to me every time that I have a conversation with an engineer in a different field. And it's totally mind-blowing. And when you talk about code to an engineer in a different field, it has a different meaning. So for us, when we talk about code, we're talking about definition 7 in the Wiktionary. And that is instructions for a computer written in a programming language, the input of a translator, interpreter, or a browser, namely source code, machine code, bytecode. That's the definition that we usually think about, right? But if you go and you talk with an electrician or a plumber or an electrical engineer and say, what does code mean to you? They're talking about definition number 3. Definition number 3 being any system of principles, rules, or regulations relating to one subject. Okay, that's what they think of when they think of code. So for an electrician, they think about this code. This is the National Electric Code, okay, the 2011 edition. And so we're going to crack open these things and see what code means to these other fields and what it might mean, what implications it might have for us in C++. So if you crack open the thing and you look at section 90.1, you get this purpose. And it's broken into 3 parts, and I'm paraphrasing a couple of them, but A, the purpose of this code is the practical safeguarding of persons and property from hazards arising from the use of electricity. Okay, fair enough. This code contains provisions that are considered necessary for safety, and this code is not intended as a design specification or an instruction manual for untrained persons. Okay, so this is like a serious document, and it's about protection of people, it seems. Here's another code. This is the 2021 Uniform Plumbing Code. And if you open this sucker up and you look at section 101.2 with scope, it says the provisions of this code shall apply to the erection, installation, alteration, repair, relocation, replacement, addition to, use, or maintenance of plumbing systems within this jurisdiction. So within this jurisdiction, we're talking about requirements, right? Not suggestions. And the purpose is this code is an ordinance providing minimum requirements and standards for the protection of public health, safety, and welfare. Okay, so we're seeing a similarity between these 2 codes in terms of what their purposes are. And one more code I want to look at is the 2021 International Building Code. So this building was built to code. And the purpose of this one is to establish the minimum requirements to provide a reasonable level of safety, health, and general welfare through structural strength, means of egress, that means like you can get out of the building, stability, sanitation, light and ventilation, ventilation obviously more important these days, energy conservation, and for providing a reasonable level of life safety and property protection from the hazards of fire, explosion, or dangerous conditions, and to provide a reasonable level of safety to firefighters and emergency responders during emergency operations. Okay, so you get the sense that these aren't style guides. right? When we talk about style guides in our organization, we talk about 79 character limit versus 100 character limit versus 120. Do you have your variable name start with a capital letter? Things like that. That is not what they're talking about in these codes, right? So just to get that distinction. So now we know what it isn't. What is it? So number one, they're about the protection of human beings. They always talk about the protection of human beings. Number two, they talk about protection of property. And number three, they talk about facilitation of emergency response. Let's look at that from the perspective of software. Starting with the last one, facilitation of emergency response. Let's say you're working with some kind of a system, some kind of a software system. Emergency response is a thing. If you've ever been through an outage or a major situation, emergency response is a big thing, and you are either prepared for it or you're not prepared for it, right? So this is one of the things that applies to all these different fields. Protection of property. This can mean a lot of different things. So the code base that you work with is typically your business's asset, right? And it is its means of like making money for the company or doing some kind of good to society, whatever it is. That is an asset, that is a property. And you can think of the importance of that for your business, right? So there are certain things, certain ways that you can develop your code that either protects your property or makes it so that it's unprotected. And we'll go into more detail about what that means, but you might think that protection of human beings doesn't apply to us, right? That's, that's not really the case. Maybe some like really narrow fields. Well, look at this. CPP core guidelines, number 11 here. Avoid calling new and delete explicitly. Now you can call new and delete explicitly and do it correctly, right? Maybe you can. You probably can't. Actually, it seems like people just don't really do this correctly, hardly ever. So it's an extremely dangerous thing that you can do to your code base. Now the implications of this could be, you're working on a Flappy Bird game, it crashes, someone restarts it. Who cares, right? But what if you're developing like some kind of software for a hospital, right? New and delete, using new and delete and putting yourself at risk of having one of those bugs could cost someone their life. Or if you're building, let's say, a huge financial engine, right, which is something that we do at Bloomberg, and something goes wrong, you get the price wrong, it could cause an international incident, right? It could cause a war. So getting this stuff right is not just about, this is good and bad, right? We hear that often in these talks, like, oh, this is good, this is bad. We have, this is safe, this is unsafe, and those have very particular meanings. But when it really comes down to it, when we start talking about codes, this is actually ethically troublesome to write code knowingly using naked new and delete, as opposed to using smart pointers or something like that. So this is like a very different way that we're accustomed to thinking about these things. But I will say that codes are not always necessary or desired. Now, and this applies to other fields too. So I'm gonna introduce you to somebody, Sister Bridget Mary. Okay, so she works at a Morning Star camp where girls go to like these summer camps and they do all kinds of fun things in nature, they pray, and she is probably one of the most cool people that I know. So you can see that she's extremely blurry in this picture because Sister Bridget Mary is on the move constantly. She's going from A to B. She is like going and fixing a toilet over here. She's doing like some electrical work over there. She's what you call a fixer, or in more common parlance, a handyman. This is what she does, right? And she does it all in full out like nun regalia, which I just think is freaking cool. So there is a use for this, right? Sometimes you want a fixer, sometimes you want an electrician, right? If you're doing something really small in your house, you can call a fixer, call a handyman, whatever you want to call it, they'll come and they'll do it for you. But there are certain things that they don't really, touch. And the difference is really code, right? Like an electrician, like a a fixer can come to your house and make some modifications to your outlet, and they can do whatever they want. They can use, duct tape, hopefully do something better than that. They're skilled. But an electrician comes to your house and they need to do something. They will not use duct tape. Why won't they use duct tape? The reason is because they are morally obliged to make sure that what they leave is in code, right? Because there are certain safety guarantees when they leave something in code. And they will refuse to do work if you ask them to do something which is not in code. There's a use for both of these. Now, is there a parallel for us? Maybe. You can think of someone that is a programmer, someone that has the ability to write code. There's a lot of things that you can do when you write code, and there's a subset of programmers that you would say are software engineers. So these are folks that will make sure that when they end with something, it has a certain level of quality, and the way we measure this quality are those three things: protection of people, protection of property, and emergency response. And there's a use for both. So when do you need an electrician? When do you need a software engineer to do something? When do you need something to be up to code? There are two different areas that I've identified as to when is the criteria you would use to do this. So first one is the system risk profile. Is the system that you're working on, does it fundamentally touch, protection of human beings, protection of property, protection or facilitation of emergency response? If these things apply to the system that you're working on, then that is when you want to have this system to be up to code, or this is going to go into your input in terms of the criteria. The second one is the change risk profile. What kind of changes are you making? Are you going in there and making some modifications, like changing comments around? Maybe you don't need a software engineer to do that. Is it something that's going to be a major refactor to the system? So is the blast radius going to be potentially huge if you get this wrong? Then you want to have a software engineer do it. And it's like the combination of these two, you have to decide what makes most sense for you. You also have this idea of old work and new work. If you go into one of those big box stores like Lowe's or Home Depot or something like that, and you go into the electricity section, you're going to see that there is a bunch of stuff labeled old work and a bunch of stuff labeled new work. And I really got confused when I first got into this, like, what does this mean? Of course I want the new stuff. That's not what that means. It means that there are some devices that you get that are specifically designed to incorporate into an old system. And some devices that you get to where you want to do it if you're doing something from scratch. If you knock it all down to like just the studs when you're doing some kind of building renovation project, you buy new work boxes. If you're not going to be taking down things to the studs, if you're going to install something into an existing wall, then you get old work boxes. So there are different techniques and different materials that apply when you're modifying old stuff and when you're doing new stuff from scratch. Anytime you do new work, if you're an electrician, you're a software engineer, it must conform to the code. There is no option of creating something new that is not going to be up to code for software engineer, electrician, plumber, whatever. Now, if you're doing a minor renovation, you may use older revisions of code. So in the example of an electrician, aluminum electric lines were a thing for a while, and then they found out that they were dangerous. So you don't usually use aluminum cables in new buildings. But if you're going and you're modifying an existing building for some reason, let's say you're putting in a new outlet, you're not going to pull out all that old cable and put in new cable, not likely. It's okay for them to leave it using the old style of cable and just be very careful when they're using the aluminum style cable, right? The same thing applies to software development, as we'll see in a little bit, that sometimes you want to, when you're doing a minor renovation, use the older revisions of the code. Major renovations may require bringing everything up to code. If you're flipping your kitchen out, just getting rid of everything, you better believe it that all that new stuff that's coming in is going to have to be up to code. Like if you have one of those platforms in the middle of the kitchen. I forget what these are called. Island, yes. If you have an island, one of the things that you must have in your island is an electrical outlet. That's just part of the code for it. Okay. For us, the vast majority of us are working with older codes, or older code bases, I should say. And so it isn't as interesting for us to talk about what it's like when you're developing things from scratch. Let me just get a sense of the room. So raise your hand if the project that you're primarily working on is something that's just completely from scratch. Okay, that's bigger than I thought. So that's maybe like 20% is what I saw. But the majority of people are actually modifying older codes. So what I'm gonna do is I'm gonna try to work through an example, a real world example, and what it would look like in this imaginary universe where we have a code. What kind of decisions would we make? What kind of things go into that code? And let's see where it takes us. So in this example, it's a piece of software called ULDB dump. Okay, and essentially what it does is it finds users that are associated with a particular resource, so you specify the resource on command line. It'll figure out the users that are associated with it using some kind of call. It'll then query more information about those users, which is using another kind of call, and then output information on standard out. Okay, and it's like in a delimited format. And this is a really small speck of a piece of a gigantic system. It's extremely old. I think that it was originally written in C. And the goal of this project that we're going to work through together is to switch the infrastructure for the lookup usernames part of it. Okay, so there was an underlying API and they said, look, we're deprecating this API. We want you to switch to this new API. So what does it look like when we execute this? So the first thing is we need to make sure that we can relink this thing. And we have this concept of TSAM level 1. There's a level 2 and a level 3, but for the context of this discussion, we're just talking about level 1. It stands for Threshold for Stability and Maintenance. And we say that a piece of software meets TSAM level 1 criteria if we know what it is, like it's somehow documented what the purpose of this thing is, we know how to build it, so that implies that we have the source code and that we can build it, and we know how to deploy it safely. In other words, we can deploy it usually in a staged way, and we have some kind of verification steps to make sure that nothing went bad as we're deploying it out. And this doesn't mean that it's automated at all. It could be like a manual process, but that's why that's just level 1. And what we're saying is that in the context of Bloomberg, TSAM level 1 is a sufficient criteria to do a relink. So you're not touching the code at all. All you're doing is linking against newer versions of libraries. If it meets TSAM level 1 criteria, then that's okay. We can do that relink, we can do that redeploy. However, when we tried to get this thing to TSAM 1, there was a problem. We had expected output, and here we have just a list of user IDs next to the users next to them. But the actual output looked like this. And we got this like first line of garbage that came out. Does anybody recognize what that first line of garbage is? Any ideas why that might be there? Error log. Yeah, exactly. So it turned out that some underlying API that we were using started logging stuff, and it logs it to standard output, which corrupts our output, right? So we discovered this we know how to safely roll things out, that there is corruption now in the output. So it's something that we need to fix. So this is what it looks like to fix the logging. We put out some logging code under there, but I want to point out this get brash Zibby function. This is clearly renamed to protect the innocent. It turns out that back in the day, it wasn't a well-established practice to use headers when you wrote C code. You could just put a little extern right there and make sure you link to the right library, and that thing just worked, right? This has nothing to do with the code change that we're making, but we noticed it. It's like, oh, there's a smell here. This is like a not good thing. So what do we do about it? Some of you might say, fix it. Some of you might say, don't want to touch it. It's working. I just want to fix the area that I want to fix. What happens when you have an electrician over to your house and they're doing something and they notice that there's something amiss? They will usually go to you and say, hey, look, I discovered that you have this dangerous situation over here. My professional recommendation is that you fix this as well as the thing that you asked me to do. Here's how much it's going to cost. And then the decision maker makes the decision as to whether they want to fix it now or later or whatever. We could do the same kind of thing when we work with our code bases. We can say, hey, I discovered this issue. This is what the cost is going to be. I recommend you fix it. Another question that we have to ask ourselves is, are we following the latest code? So this version of the logging stuff, this logging boilerplate, so this is making it so that all logs go to standard errors instead of standard output. This was copied from another file. Someone found another file where logging was worked and then copied over into this file. You might notice when you're looking at this, that last line there, logger manager shut down singleton, feels like RAII should be used here as opposed to something like this. There's a lot more other questions you might have about this. It turns out that a new revision of this library came out, and while this compiles and works just fine, the new revision came with a new recommendation on how to initialize the logger. So when you are bringing something up to code, you have to make sure you are using the latest revision of the best practice as you're using it. So here is what this looks like now. And you can see that now we have this scoped guard thing, so this will do the logging thing. Now you might notice, look at all that like allocator stuff above it. There's a whole different conversation that I don't want to have right now about how dangerous things can be. Like allocators themselves are extremely easy to get wrong. Think twice before you put it in your interface, because it could end up being a safety hazard. But I'm not going to say anything more about allocators. So this is an idea of what the old API looked like that we need to replace with the new API. There's this function, get UUID name. It takes in username length. So this is like the string that it's going to fill in. And it takes in the UUID, and it queries something, does something, and then puts it in that string. Okay, and then it loops over. And you can see right here that it prints out in this record format what the output ought to be. Okay, this is just what it is. And we're going to take a look at what the new API that we need to switch to, how that looks different. Turns out it requires a lot more code. So now, instead of just saying, give me the user's name, you say what kind of fields you want to query out of like some kind of database. Presumably there's more information than just the name there. They got generic and so on. So you have to now say which fields you want. There's a bunch of boilerplate, and I'll just say that it's boilerplate. It turns out that the new interface provides a type for a user, a new user type. So we'll consider as to whether or not we want to use that in a sec. Now, instead of taking in an individual ID, it takes in a list of IDs. You've got more boilerplate to iterate over the results. Now you have the modified output. Again, we're using printf here, and then you have some kind of error handling. Now, if you have someone which would qualify as a fixer, they might go into this old code and replace that old code with this new code, right? But this isn't what a software engineer, in my mind, would do. There's a lot that can go wrong here. You could do mistakes in that boilerplate. You could mess up the output format so it's no longer compatible. You can screw up error handling. There is so much that can go wrong when you just take that old piece of code and replace it with this new big chunk of code. So I'm claiming that last slide that we saw is not up to code. But it might be useful as a prototype, and you're incrementally doing software development. So what would up to code look like? What are the things that we would touch? Right? So architecture is going to be really important. Why is architecture really important? Well, if it's architected to be testable, that can help protect your property. It can help facilitate emergency response. If it's a big mess of spaghetti code and people can't get in there when something major happens, then it's a risk. Coding standards are important. Why would coding standards be important? Maintainability. the better you are able to modify your software because of consistency, any of these kinds of things that go into it, you're protecting your property, you're protecting your software asset. Testing is obviously super important for protection of human beings, protection of property. Documentation, nobody likes writing documentation, right? It's not the fun part of coding a lot of times, but it can facilitate emergency response. Something happens, someone goes into a code base, they're trying to figure out what's going on, this thing is documented, okay, I've been able to figure out the issue. No documentation, good luck. It's gonna take hours later, days later, I don't know. That could be life and death. It also is, again, for maintainability, for protection of property. The more easily you are able to extend your software, make modifications to it, improving your time to market, all this is protecting your software capital property. So a big part of architecture is what vocabulary types are you using for your system? The idea is to build a common language that you can use to reason about your code. So one candidate here is this user accessor API user data type. Okay, and you can see what it looks like. So first we have this, like the function signature that we're going to be calling the new function that we're using, and then we have the user thing that comes along with it. Now you might think, well, it's there, we could use it, but there are a few problems with this type. One is there are a lot of things that we don't care about here, right? We don't ever think about phone number or customer number or any of this other kind of stuff. But an even bigger problem is that all of these things are nullable values, which is really just like std optional. If you have a data type which you're using which has all these nullable values, every single function that receives one of these things as a parameter, you have to now explain how is it going to deal in these situations where these fields that we expect to be there, like first name and last name, are not there. It makes it more complicated. The more complicated something is, the harder it is to modify, the harder it is to have emergency response, all this other kind of stuff. So here we're not going to use this as our vocabulary type. It doesn't meet the kind of safety criteria we're looking for. So let's make our own. First one here is user ID. Here we're developing a class. It has one private member called DUUID, and then it has a bunch of accessors, a creator, has a stream, and all this other kind of stuff. Why do we want to create an abstraction on top of this int here? The reason is because ints can be negative, and UUIDs are never negative. So if we wrap up this int into a watertight type, then we know that if we receive a UUID, it is always a valid UUID, or it always is a actual UUID. And then we have some aggregates here. So these are just plain structs, they're not classes, they're not abstracting. And the reason that we can have aggregates is we know that every single combination of values for these different member variables here still amount to a valid value of this object, right? So we have our dump record, this represents one line in our output. And then we have a dump, which is a collection of these lines in our output. Everything makes sense so far? Not too hard, right? So in this file here, we're going to collect the different dump-related types and functions. The first thing you'll notice is there's some documentation up here at the top. We want to document the purpose of this header file, and ultimately the component that this header file is part of. We have the description, and we have a documentation of the format that this file, like the actual character format that this file is using, and it's important for it. It might seem like, man, this is a lot of documentation, but this is necessary if you're going to do serious software engineering. So it's going to be part of the job. So here we're using a utility class. So this is a way to make a closed namespace. So in the style in Bloomberg, we typically use these as opposed to namespaces. There are some benefits to it. And we have our serialize function here. So remember before that there was this like print, there was these printfs? We're not using printfs. What we're doing is we have an interface which takes in an O stream and a dump, and then we put it into the O stream there. This is a testable idiomatic interface. We can now test this without having to actually execute the application and look at the output. And the next important thing to look at is contracts. So here we have what looks like documentation of a function, right to the specified stream, the specified dump in user dump file format. And we can use that term, user dump file format, right? Because we define it above. This function will have no effect if stream is not valid. So this is using very specific language. This isn't just documentation of a function. There is a BDE style contracts, and there's part of the BDE standard. You can look at it online, and I have the resources attached to this talk, to spell out in a very structured and specific language what the semantics are of the functions that you're writing or calling. Why would we want to do a contract? First nice thing about having a contract is it indicates where bugs are. If a function declaration has a contract associated with it, then you know that if something goes amiss, it's either the caller of the contract which is breaching the contract, or it's the implementation of the contract which is breaching the contract. If you don't have contracts, you can't really talk meaningfully about where a bug is in a system. It improves usability because people are able to look and identify what the function does. They understand what guarantees they get out of this function, the things that they are okay to depend on, the things they are not okay to depend on. So that's really nice. And it also guides black box testing. So when you are looking at an interface, you can look at the contract, and without looking at the implementation at all, you have the ability to write some test infrastructure around it and test that thing in a black box way. This next slide is talking about, is going to be where we are working with this API data type and we're converting it into our strongly typed data type. Okay, so again, you have this documentation in the front of it, and we're defining what a valid user is in the context of this application. So a valid user is going to have certain fields in that user struct that are going to have values, and that's what a valid user is in the context here. So once we define what a valid user is, we can use it in our contracts. So in this one, we have our isValid function, which returns bool, return true if the specified user is valid and false otherwise. Pretty straightforward. Here is something completely separate. We're doing idiomatic library usage here. So this particular application needs to compile in a C++ 03 context, so we're using Boost algorithms all of. I think this now in the standard library as well. So you would use that for when you can use the newer versions of the standard. But using libraries in an idiomatic way, as opposed to spelling it out, again, reduces the incidence of bugs. Bugs which could cause property damage, human damage. When you have an unsafe function, or we have a narrow contract, you need to make sure you specify what the valid inputs are. So here, the second line of this documentation is the behavior is undefined unless user is valid. And if you're going to have these kinds of contracts, you need to make sure that you assert inside the body of your function, you just need to confirm that the user did indeed meet their end of the bargain. Now, in completely correct code, you don't need these here, right? But there's no such thing as completely correct code if you're talking about systems of any reasonable size. So these kinds of safety checks can actually make a huge difference. And here's another function here. We have dump from user, so we create our dump out of our vector of users. I just want you to note the testability of all the functions that we have. It's so easy to write unit tests for these functions. They're pure functions, there's no global state, there's no external dependencies. Everything is working, everything is written in a very testable way. So this is something that you would expect in software that is going to be up to code in our imaginary code. Now this part is a little bit different. So remember we had all this boilerplate that we needed to use in order to be able to call this underlying function. There's a lot that can go wrong here. There's even more boilerplate there. And then we have this environmental dependency which prevents unit testing. So when we call this API to say, hey, give me the user info by UUID, in this particular case, is calling out to an external service, which needs to be running on this machine or accessible from this machine, and then it will return the data. The problem here is that you can't really unit test something which has an environmental dependency. So the way that you solve this, or one way to solve this, is by using dependency injection. One way to do this is using inheritance. So what we do here in this example is we have our struct, which is representative of this API call that we want to call. It has a single operator, call operator, so a single member function here, that has the exact signature of the thing that we're calling. All right, so it's a pure abstract base class. Then we have a concrete implementation of this, which just calls that underlying API. Once we have this, now we can take that dump from UUIDs function and add an extra argument, which is our dependency which we're injecting. And we default initialize it to the implementation which does the real thing. So now what can you do with this abstract base type? Well, now you can inherit from it and you can check a bunch of different things. So you can unit test the arguments passed to your dependency to make sure that you're calling the dependency with the right arguments that you expect, like maybe those particular fields you want to verify that they're being included when you call your dependency. You can unit test now various dependency outputs. Like let's say your dependency that you're calling has like an error return. Well, now you can actually check to make sure that the error, that under that behavior, when it does return an error, that your code works properly. And I'd go even further, and I would say that up-to-code APIs should provide these kinds of primitives that people can use to verify their own software. Now you might say like, well, but they could just do it themselves and I don't need to make their decisions for them. But think about it like this. If you go and you buy a bookcase and you install it, they come with a little strap which you attach to the top of your bookcase and you attach to the back wall. The reason that it comes with this is in case a little toddler comes along and climbs up the thing and the bookcase falls on them and causes human damage, right? Now the bookcase manufacturer could say, look, I don't know if you have toddlers. If you want to go and buy a strap, you can buy that independently. It doesn't have to come with a bookcase. But the thing is, if it's included with the bookcase, people are more likely going to use it, right? Which means ultimately fewer squashed toddlers. And so the same thing applies to code. If you provide these dependency injection primitives along with your software, people are more likely going to use them and verify that their own code is correct. So it does make a difference to the safety of your software. Failure reporting. So when it comes to failure reporting, we know that we have a lot of different options in C++. I really like the safety benefits of using exceptions. Performance is a completely different topic, right? But when it comes to like pure safety, the danger of someone ignoring your return code, well, let's say people just ignore the failures, right? In both situations. People ignore the failure with exceptions, it gets propagated up, usually to some top-level try-catch thing. If you ignore the failure and it's a return code, then the code just keeps on like rushing on through, as if it didn't happen. The behavior where it propagates up, in most contexts, at least that I'm familiar with, is a better default behavior. It's a more safe behavior. I could see where in other contexts, maybe you do want it to like plow through. But that's one of the nice safety benefits of using exceptions, is it has that default right. Another key thing to take away from this particular snippet here is you shouldn't assume the validity of external services. Just like we already know that it's good practice if you get user input that you have to validate it, right? You don't just throw it to something which has undefined behavior if the user typed it in wrong. The same applies to external services. So in this code, we are making sure that the result of our underlying API call is valid before we go on and do undefined behavior or whatever else might happen. there is other testing that is important for people to do. There's integration testing. Are we sure that our software is interfacing with this other dependency, which is like another program running next to it safely? Does it work properly? That's integration testing. Environment testing is another one that I think is getting more and more visibility in the field. And that's to make sure that when you install a piece of software on a system, if it has a dependency on some kind of piece of the environment, you can deploy it and have some kind of checks to just make sure everything is in operation. All right, some kind of health check to just make sure that things are cool. If someone took down that service that we depend on underneath the hood, we want to find that out in our testing rather than from our customers telling us something is amiss, right? So these kind of like health checks are extremely important. And then finally, getting some kind of automated system testing. When you put everything together, is your whole system doing the right thing? Is it behaving as expected? You can't get away with never actually running your code, right? Like the full version. Unit tests are definitely not enough. The next topic here is inspections. In other engineering fields, inspections are a part of like day-to-day life. All right, they happen all the time, starting with a plan review. If you're going to make a big expansion to this hotel, they're not going to go ahead and start working on it. They're going to write up some plans, and these plans need to go to an authority, and the authority will verify that the plans are safe, in code, as expected. They're not looking at your plans so that they can say like, look, this is going to be hideously ugly, right? That is not the intent of one of these inspectors. They're looking at it for safety. Again, protection of people, protection of property, facilitation of emergency response. So we have this in software development. We have design reviews. We have API reviews. We have rollout reviews when they ask the question like, hey, if you need to roll this back, how are you going to do that? Do you have a plan ready to go in case something goes wrong? And then once your plan gets, rubber stamped, you need to go ahead and implement your system. You need to do your thing. And then again, you have another inspection. These people are now verifying that you did it according to your plan, that your actual implementation of this plan meets our safety standards, meets the requirements. So this, for us, is kind of like a code review, right? A particular kind of code review. Not one that, sweats the, weird details and things like that. No, it's just more of like a safety review of this code. Is it meeting the specification? And then finally, in other fields, they have condition surveys. Every once in a while, someone's going to come into this hotel and is going to verify that things have structural integrity, that nothing changed into a way that would be outside of code. Maybe there are things that, maybe the code changed and they realize, oh, by the way, like this electrical panel or whatever, we're not doing things this way anymore. This is something you need to fix right now. Going through your existing systems and trying to figure out if they are maintaining their integrity from a code perspective. I put question marks here because as far as I know, we don't even have a word for this in our industry. This is not something that we talk about. I'm sure that it's happening in some context, but it's not like in our thinking at all. And I think it just points to the lack of maturity of our engineering discipline and how much more we have to grow before we can be considered on par with these other engineering disciplines. So I want to summarize now. Other engineering disciplines have codes, right? And they're there to protect human beings and property, facilitate emergency response. I think we should have some. Codes and software engineers should be used when the system risk or change risk is high, right? This is when we should be applying codes. And codes apply to both new work when you're developing something new or when you're doing renovations on old work. Frequently this last one is missed in practice. Someone's like, but I'm modifying this file. It is like hideously ugly. If I touch it here, it's no less ugly. That isn't enough. And some of the particular details when it comes to C++, we have use standards. We talked about TSAM. There are the CPP core guidelines. There's the BDE standard. There's a lot of things out there. There's even a MISRA standard. So there's the automotive industry got together and they wrote something which looks like a code for developing C++. And you can check out the MISRA standard in the links at the end of the talk. We should be following best practices and idioms, focus on what can go wrong, not on what looks good. And we need to build consistent vocabulary. This is part of our architecture, using watertight types, using contracts, other documentation, design for testability, utilize inspections, and formalize inspections. There are some takeaways I would like to emphasize with this talk. The first one is that the software that we're writing does put people and property at risk. And you don't have to really think that far to understand how tightly we are coupled to this thing, okay? Like, it's very rare when people are writing software which doesn't have this property. So it is important. It is something we need to start thinking about or start thinking more about. The second one is that software engineering really needs to mature badly. The amount of software that we are depending on as a human species is increasing astronomically. And it is absolutely outpacing our software engineering maturity, right? Just consider, just like as a thought experiment, think about some software which you saw recently, which is part of a system which is really important, that would not have like any of the qualities that we're talking about here in terms of safety. And that's being written all the time. We gotta get better fast. Otherwise something will happen. Ergonomics is a safety feature. You know, we think about like ergonomics, like this is an ergonomic chair. Oh, that's nice because that means my back won't hurt and, you know, help me from things. When we think about ergonomics in software industry, we frequently think, oh, if your library is more ergonomic, you're going to get more adoption. And that's great. Of course, if it's more ergonomic, you're going to get more adoption. But that's not the important part from a software engineering perspective. The easier it is for your software to be used in a safe and correct way, the more safe your software is going to end up being, right? That's really why ergonomics are so important. And languages need to evolve to better support software engineering. If you're writing some C++ code, and you're a new developer, and you want to write some tests, what support does C++ have for you? As a language, not a hell of a lot. You gotta learn like to pick up some kind of other library, maybe pick up GTest or something like that. You gotta write your tests in a separate file. Documentation's gonna be library specific on how to do that. The story isn't great for testing in C++. Compare that to something like Rust or something like Swift, where the testing is actually built into the language or built into at least the standard library. We need our languages to support and like software engineering practices. Now, a comment that an engineer at Bloomberg gave to me after seeing this talk is he said, look, I think that one of the problems that we have is that our communities are based on languages, right? This is a C++ language community. So we talk about things in the context of C++. Oh, this is nice to do in C++, and so on and so forth. But in order for us to mature, as a software development peoples, it's important for us to consider ourselves software engineering communities. C++ is a tool that we use for a particular purpose. I don't know exactly if I agree with that 100%, but I think it's an interesting idea about what kind of communities we should be building in order to build a better life for people. And finally, the conversations about safety and software ethics needs to expand. I very frequently hear people trashing developers, which happens all the time, right? Let's be honest. They trash other developers like, oh, look at this crap code that this developer wrote, right? They don't know how to write code. You know, I could write code better than that. Fine, that's always going to happen. But I would like to transition this to where we look at a piece of code and it's no longer, oh, they develop crap code. It's like, I am concerned because this code is written in such a way that puts people at danger or property at danger. I think that it was unethical how this code was written. And we can start having these kinds of conversations. And I think that it's very important for us to transition to be thinking in this way. So that is the end of this talk. Thank you all for listening. Appreciate it.
So this is less of a question, more of a comment on one of the points on the last slide where you were talking about how software engineering needs to mature, otherwise something's going to happen. And I would argue that many things have already happened. I just did a quick search and saw that there's been at least one person who's died of getting hit by a self-driving car. And I'm sure there's a lot of other things that have happened due to an oversight in code quality. So I think things have already happened.
Yep, that's a really good point.
Hi, how's it going? I think one comment, you said that we don't have condition inspections, right? But we do. It looks like static analysis passes across entire code bases, right? Where we can identify, hey, you're using something that's out of code because it's been deprecated, or I can actually identify, you can be dereferencing null pointers in these situations. So it's just that it's not a disagreement, I'm just saying, like, maybe we could fill in some of those question marks with, and this goes to my actual question, something I didn't hear a lot of, other than maybe a slight reference to documentation generation, is how tooling is important to staying up to code, and whether we as an industry or like how we should incorporate that into like your thoughts on like how code works and how we should keep our code up to code, right? Yeah.
Yeah, I think that's you raise a couple of really good issues. I'm going to start with your second one because I have the brain of a bird, so I can only remember the last one. And that is the tooling. A lot of times when people talk about bringing software quality up, they often precondition it with, well, make the tooling, make it easy for me, and then we're going to have, then we'll have the software quality up to there. And while I totally appreciate the sentiment, I think that we have it backwards. I think that we really need to start with the quality needs to be at this level. We need to meet these requirements. And now let's have the tooling make it cheaper for us. Because if we don't start with, we're going to have the maintainability we're going to have the quality at a certain level, then we're always going to be behind the level of where the quality is sufficient for safety. So with regard to your first comment, remind me what it was?
It was just that static analysis tools themselves do provide that condition analysis that you're looking for.
Yeah. So static analysis tools, I think, are useful in that sense, but that does not replace a human being going in and looking at code and applying their software engineering skill set as a whole, totality, when they look at code. There are certain things that, yes, static analysis tools can do, but they're never going to say anything about architecture, for example. They just can't do that. So I think that while it's useful, I think we still need to have a human component if we want to mature like other engineers.
I don't disagree with that, but I would also clarify that even architectural standards, there can be indicators that would inform an inspector that there is an architectural problem going on. For example, you can do cycle analysis on complexity analysis on data structures and functions, and to say, like basically with the tool, say, there's a mess of wires behind this wall. This is something you should be looking at, that kind of thing. And that's very useful, right?
I totally agree. And one example of this is when you take your car in for an inspection, if it's a modern car, they plug that sucker into the computer and say, hey, is anything wrong?
Right, and you're not up to code if you don't have a plug for that analysis to take place, right?
Yep.
Thank you for the talk, very excellent talk. One thing I like to say is about you were talking about the plumbers and electricians, right? But in terms of their safety, like the code is half the story. The other half is apprenticeship, right? Like before an electrician does it, like they had to like serve like 4 to 5 years as an apprentice under a manual, under a master electrician, see how they do it in the real world, how the code applies, how it internalizes. I guess the analogy for our thing is like mentorship. And we as an industry, I don't know how much we do enough mentorship in growing people. Like, hey, this is how you do it. You learn the intuitions, you learn that. Do you have any ideas like what we can do as an industry to support mentoring and like kind of the apprenticeship, like not just having a code out there, but like helping people internalize it by watching people in action following it?
I think that you raise a really, really good point. And I agree that apprenticeship should be part of it. It would be good for us to start by just defining what it means to be a software engineer. We have a code, and then we can start talking about the training that's necessary to get there. We're so early in this, but we can learn from these other fields on how they do it. Absolutely.
So you mentioned quality, and quality is one of these complicated words that a lot of people have like a surface understanding, but that ignore what it actually means. And when we talk about quality in engineering, we're usually talking, well, in other fields, we usually talk about the quality of this steel is that if you test it this way, it will produce these results within this error margin. And I think the subtlety here is that I don't know that we have the metrics defined for how we even define what is software quality in that respect. Like, how can we establish, like, how can we say, like, I want the code to have quality, but then how do I test the quality? Because that's the definition of quality that's actually useful, is like something that you can test against a measurement to define how much quality you have.
Yeah, and thank you for bringing up that point. The quality, as we normally think of it, is very subjective. People will argue until they're like blue in the face about what's better quality, right? One thing that I like about these other codes that I saw is that they provide what the metric is. It's still a little bit vague, but they concentrated on protection of people, protection of property, and emergency response. So I think that this is a good basis for comparison when we're looking at different options about what we want to be up to code or what is meeting like level of quality. So yeah, thank you.
Hi. My question is kind of an extension of the previous question about the analogy that you used. So the distinction between a handyman and an electrician is kind of more formal, where an electrician typically needs to undergo retraining so that they are up to date with kind of the latest code. Or in terms of manufacturing, you have something like a Six Sigma training. And there is no such formal distinction in terms of what you described as a programmer and a software engineer. So do you see that happening in the future, or I am not aware of any such kind of requirement that is there, that is specified by any of the standards. So is there any such requirement that any of these standards mentions, or do you see, what are your thoughts on it basically?
I'm not aware of any formal certification for software engineering. They may be out there. I think that eventually we will, right? 50 years from now, we're going to have certifications for people doing software development. The question is, how soon can we get there? How many more disasters need to happen before we actually start doing this kind of thing?
I think such kind of formal definition also leads to a notion of accountability. So I think that would be kind of nice to have.
Yep, definitely.
Just wanted to do a quick follow-up on that. Uncle Bob has that talk that he gives, and he says that if we don't come up with our own code, the code is going to be imposed from outside, and that's much worse.
Yeah, good point. All right.
So there is a standard for who's not considered a software engineer in the United States. So the American Board of Engineers licenses professional engineers, and you have to be licensed under NCES. and they have all these standards. And they'll point you also to ASTM standards, which is what the rest of the engineering community uses. So if you're interested in protecting life safety and things like that, the rest of us, chemical, mechanical, electrical, everyone else, that's how we get licensed. It has a 4-year apprenticeship where you have to work under a professional engineer. You have to take 2 exams, or each 8 hours a pop. So there is a mechanism if you're interested in pursuing something like that. The other thing I was going to add was I thought this was an awesome talk because I think about it all the time because I deal with health and safety issues related to my code, especially doing chemical engineering. And the only thing that I didn't see was a lot of times for really hazardous situations, 2 separate groups or 2 separate engineers have to solve the same problem in complete isolation. So if you drove here on a bridge, it was probably solved that way. And those 2 people have to come to the same solution, otherwise they break out and they do it again with more engineers and more have to come to convergence. And because software isn't always the same solution for the same problem, but getting to some common standard at some point where everyone's solving to a pass-fail, that'll be a challenge. So, great talk.
Oh, thank you. So we are out of time. Thank you all. Enjoy the rest of your conference.